So we are looking at determinant of a matrix. So we have looked at the dimension of a matrix, addition and subtraction of a matrix, multiplication of a matrix. Now we have determinant of a matrix. Normally, shortcuts, that. Look at it for 2 by 2 matrix and 3 by 3 matrix. So for a 2 by 2 matrix, given that A is equal to A, B, C, and D, the determinant of A, matrix A, which can also be written as this. The formula is that you multiply the diagonals. So you multiply the diagonals, but you subtract the second one from the first one. So the first diagonal is this. So I have A multiplied by what? D. Then I'll have B multiplied by C. I'll have BC. Then I'll subtract. So that becomes the determinant for A, matrix A. Matrix A. Worked example. I'm using the matrix A I gave for the other things that we did for multiplication. So given that A is equal to 2, 4, 5, and 6, determinant of A will be what? 2 multiply 6. So you have 2 times 6 minus 4 multiply 5. So you have 12 minus 20. So it becomes minus 8. So the determinant of A is minus 8. Now take very note of this. This symbol has many definitions. So it depends on the topic you are using it. So this can represent absolute. So if it is in terms of absolute, when I say absolute value, so absolute value gives me positive. So even if I have A minus A, absolute of minus A gives me A. But in this case, we are not looking at absolute, we are looking at determinants. So if it's under matrix, when you see this, it is not about absolute, it is determinant. Under geometry, when you see this, they may be talking about the magnitude of, that may be a vector, they may tell you the magnitude, you may see AB. So that may be standing for the magnitude. But this is matrix, so it is determinant, not magnitude, neither is it absolute. So this is the determinant formula, this, and that's what we got. So look at 3 by 3 matrix. So look at the determinant of, so for 3 by 3 matrix. So pay attention to this part, A, B, C, D, E, F, G, H, I. I'm going to 3 by 3 confuses people. So for 3 by 3 matrix, the determinant is such that determinant of A. So I'll do something like this. So I'll bring the determinant sign A, B, C, D, E, F, G, H, I. Meaning I'm finding the determinants. I have to find it. We assume that this is plus, minus, plus. So what we do is, you take the first, we are interested in the first rules, and we'll do some gymnastics. So the first row is ABC. So I'll take the first row, first entry, which is A, but the sign allocated to it is a plus. So we have, I won't write plus A, I'll just write A. And when I take the A, what we do is cancel this row and cancel the column. We will be left with E, F, H, I. So after bringing out the A, we find the determinant of E, F, H, and I. Note, we have done determinant of 2 by 2. So it means that we go and we come and apply determinant of 2 by 2, even in finding determinant of a 3 by 3. So that is the first one. Then, after I'm done with the A, I'll come to the B. So now I'll come to B, but the sign allocated to the B is negative. So the negative. So I'll bring minus B. So I'll cancel the column of B and the row of B. So I'll be left with D, F, G, I. So I'll find the determinant of D, F, G, and I. Then I'll be left with only C. So the last column here is left to C. I'll come and take C. The sign there is plus, so plus C. I'll cancel the column of C and the row of C. I'll be left with D, E, G, H. So D, E, G, H. We know how to find the determinant of 2 by 2. So go ahead. So this becomes EI minus FH minus B, then DI minus FG plus C, DH minus EG. Then if you give the values, you just solve and you get the answer. So take example using this 3 by 3 matrix. Find the determinant of that. So work the example for 3 by 3. Given that A is equal to 1, 2, 3, 4, 5, 6, 7, 8, and 9. Find A, that is determinant of A. So solution. So we have one determinant of A, the symbol is there. So we assume is what? Plus, minus, plus. So we take the 1. When we take 1, we cancel the column of 1 and the row of 1. We'll be left with this one. So find the determinant of 5, 6, 8, and 9. Then it's supposed to be about that we assume that it's plus, minus, plus. So we have minus 2. So with this we have to take notes. Assuming this was already minus 2, this will become minus 2. So that it becomes what? Positive 2. So you have to take very note of this one. It confuses some people. So we have minus 2. So then we cancel this column and this. When I cancel this and this, I'll be left with 4, 6, 7, and 9. 4, 6, 7, and 9. Then I'm left with plus 3. So plus 3. So I'll cancel this and this. I'll be left with 4, 5, 7, and 8. 4, 5, 7, and 8. Okay. So I will apply the 2 by 2 matrix that I determinant that I know. 5 by 9 will give me 5 by 9 minus 6 by 8. 4 by 9 minus 6 by 7. 4 by 8 minus 5 by 7. So I have 1, then into brackets 45 minus 6 by 8 is 42. Minus 2. 4 by 9 is 36. Minus 42 again. So 6 by 8 is 48. 6 by 7 is 42. Sorry, thank you. So I have 3. Then 4 by 8 is 32. 5 by 7 is 35. So 45 minus 48 gives me minus 3. Minus 2 here. 36 minus 42 gives me minus 6. Plus 3. Then 32 minus 35 gives me minus 3. So when I expand, I have minus 3 minus 2 minus 6 gives me positive 12. Then 3 times negative 3 gives me minus 9. So I would like the negative. So I have minus 12 plus 12. So this one, the determinant will be equal to 0. So the determinant of A, matrix A, is equal to 0. When you have a textbook, you can try and solve more questions. And you can also try the past questions If you are applied in economics and finance, you can get questions that deals with multiplying, defining the determinant of a 3 by 3 matrix, and you apply to find the determinant.